Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. So today we will continue with 8.2 asymptote. So I think we're gonna finish quite fast today. Harapannya tak tahu lah. Hari tu pun harapan nak habis cepat, lalu lambat juga. Tengah fikir, nak buka tak nak buka kamera ni. Buka tak buka. Apalah, buka je lah. Biar je lah. Okay, so before I start, is everyone here? Semua orang dah sampai ke? Belum lagi. Say hi if you are already here. Say hi, please. Oh, dia tak masuk dekat saya punya ni. Patutlah, saya tak nampak. Oh, hi. Kat sini baru perasan. Dan you. Okay, so 8.0, limits and continuity. So let us start then. It's already 12:03, so let us start straight away. Okay, so today we are going to do 8.2 asymptote. So we are talking about asymptote, which means today we are talking about the vertical asymptote as well as the horizontal asymptote. So that is our learning outcome for today. At the end of the lesson, you should be able to find the vertical and horizontal asymptote. So normally vertical, I'll normally noted them as VA, this is HA. So that is our aim for the VA and HE. Vertical and horizontal asymptote. Right, so asymptote, what is the definition of vertical asymptote? So a line x equal to A is a vertical asymptote of the graph of a function y equal to fx if either the limit for x approaching A from the left-hand side for fx is equal to positive infinity, or you might get negative infinity as long as that is an infinity. Or another one is that the limit for x approaching A from the right-hand side of a function fx is equal to positive or negative infinity. So you can either approach A from the left-hand side or right-hand side, and the value will need to become positive infinity or negative infinity. So as long as we do get something with infinity, we can say that x equal to A is a vertical asymptote. Right, so now let me ask you one thing. If you have a function fx, when can we get an infinity, either a plus or a minus? So this one we already learned yesterday, but since we just started, let us do a bit of recall sikit. When can you get an infinity? Do you guys remember how to get an infinity actually? Ingat ke macam mana nak dapat infinity? Cuba tulis. How can you get an infinity? By the way, limit for x approaching infinity is invalid, okay? Yang ni tak valid lah, tak boleh. Saya nak satu nilai. How can you get an infinity? Or something with undefined. How do you get undefined? Tadi ada kot tutor saya duk sebut undefined. So, how do you get an infinity or how do you get undefined. Anything divided by 0. Very good. So as long as you have a fraction and you need to divide them by 0, we are definitely going to get an infinity. The limit for x approaching 0, so not necessarily, sometimes we do get some value. Limit x approaching 0. Sebab kadang-kadang limit for x approaching 0, let's say 2x, we are going to get 0. So 0 is some value, it's not infinity. So kita tak boleh kata yang ini dia dapat infinity lah. So yang Yifang tulis tu okay. Anything divided by 0, as long as you have something divided by 0, it will become infinity. Kecuali kosong per kosong lah Okay, so now if we go to the first example, find the vertical asymptote of fx equal to 1 over x squared. So let us think a little bit. If I want to make sure my denominator is equal to 0, what is the value of x? Okay, so x squared is equal to 0. So that means the value of x need to be 0. Therefore, if you test them, the limit for x approaches 0 from the right hand side of 1 over x squared, we do get positive infinity. And the limit for x approaching 0 from the left hand side of 1 over x squared, that is also positive infinity. Therefore, we can easily conclude that the line x equal to 0 is a vertical asymptote of fx. Okay, so is that clear? So referring to your denominator, check your denominator, you let them equal to 0 and check what is your value of x. So x squared equal to 0, that means x will be equal to 0. So therefore, you check the limit for x approaching 0 from the left hand side and right hand side. So either left hand side or right hand side, they will give you something with infinity. Therefore, we can say that x equal to 0 is a vertical asymptote for fx. Okay, so next, another question. Determine the vertical asymptote of, so the first one, we got fx equal to x plus 3 over x plus 2. Another one is fx equal to 1 over x squared minus 1. And then fx equal to 2x over x squared minus x minus 2. Okay, so how do we make sure that our denominator is equal to 0 over here? If you want your denominator equal to 0, the value of x need to be negative 2. If you want your value of x equal to 0 over here, then that means the value of x will be plus or minus 1. For here, if you want your denominator equal to 0, so it might be 2 or negative 1. Ya ke? 2 and negative 1. Tak apalah, kita check Okay, so now, function fx equal to x plus 3 over x plus 2. So for fx to be undefined or for fx to be infinity, that means our denominator x plus 2 need to be equal to 0, which let me know that the value of x need to be equal to negative 2. So by the definition of the vertical asymptote, I have to check the limit for x approaching negative 2 either from the left hand side or right hand side. So either, tapi biasanya untuk saya nasihatkan check dua-dua lah, left hand side and right hand side. Okay, so negative 2 from the right hand side of x plus 3 over x plus 2. So it will become negative 2 plus 3 over 0 with a plus. So how do we get 0 with a plus? So this is negative 2 on the right hand side. So adding 0.1 to it. So this is negative 1.9. So negative 1.9 plus 2. I do know this is 0 with a plus. So I got 1 over 0, which is definitely positive infinity. Therefore, you can say that x equal to negative 2 is a vertical asymptote. So sepatutnya dia test salah satu pun dah cukup. Tapi kalau untuk saya galakkan awak test dua-dua lah. Biasakan diri sebab kita baru belajar kan. So we are just we just learn how to use limit or how to find the limit. So for me, I'll say do a lot of practice. That will be a good practice for you. So that is why I ask you to do from left hand side and right hand side. So another one, let me do that for you. So this is the limit for x approaching -2 from the left hand side of x plus 3 over x plus 2. So substitute here, we got -2 plus 3 over, this is 0. So I need to know, is it 0 a plus or 0 with a minus? So -2 on the left hand side minus with 0.1. So this is -2.1. So -2.1 plus 2, this is 0 with a negative. So we got 1 over 0 negative. So this is negative infinity. So we do get negative infinity for them. So that is why we can make a conclusion. X equal to -2 is a vertical asymptote. Right, next. B. We got fx equal to 1 over x squared minus 1. So of course, in order for fx to be undefined, so x squared minus 1 need to be equal to 0. Therefore, if you factorize them, you're going to get x equal to 1 or x equal to -1. And of course, we have to test them back. So go back to the equation and substitute. So for x equal to -1, so just in case you couldn't see, this is the limit for x approaching -1 on the left hand side. So the limit as x approaching -1 on the left hand side for 1 over x squared minus 1. Saya tak nak bagi tulis. Okay. Right, so substitute. You are going to get 1 over 0 with a plus. So this is definitely positive infinity. Okay, so let me do another one for you. So this is the limit for x approaching -1 on the right hand side of 1 over x squared minus 1. So we got 1 over, this is 0. So -1 on the right hand side plus with 0.1. So this is 0.9 with a square. So testing using your calculator, if you take -0.9, you square that number, it will be a positive number, but of course less than 1. And then you minus with 1, so this is 0 with a minus. So this is negative infinity. Okay. And then for x equal to 1, so this is for x approaching 1 on the right hand side. 1 over x squared minus 1. So substitute x with 1, we are going to get 1 over 0. So it will become positive infinity. So let me do another one for you. So this is the limit for x approaching 1 on the left hand side of 1 over x squared minus 1. So substitute x with 1, we are going to get 1 over 0, which is definitely infinity. But to decide whether is it a plus or is it a minus, we got to substitute a few number. So this is 1 on the left hand side, I minus with 1, so this is 0.9. So 0.9 square definitely less than 1, so this is minus. Okay, so that means we can say that the line x equal to 1 and x equal to -1 are vertical asymptote of fx. So when we try to substitute, we do get something with infinity, so that means they are definitely vertical asymptotes. Okay, so number 3, fx equal to 2x over x squared minus x minus 2. So let me give you a few minutes for you to try them. I think 4 minutes will do. So saya bagi masa dalam 4 minit lah untuk try dulu . Right, so 4 minutes to answer this question. So at 12:20, we're gonna check your solution. Untuk yang baru sampai, welcome everyone. Itulah. Ini je nama penuh kat situ. Lupa nak baca ni. Okay, 1 more minute to go. Check your progress. Terang sangat silau. Okay, so it's 12:20. So let us check your progress then. So in order for fx to be undefined, we got to make sure the denominator equal to 0. So x squared minus x minus 2 equal to 0. So we got x, x2, 1, 2, x. So minus plus. So we got x minus 2, x plus 1 equal to 0. So either x equal to 2 or x equal to -1. So it simply means that we will have two vertical asymptotes. So now let us substitute the value in. So for x equal to -1, we got the limit. So this is x approaching -1 on the right hand side of 2x over x minus 2, x plus 1. So substitute x with -1, we are going to get 2 times -1, -1, -2, so -3, -1 plus 1. So this is 0 with a plus. So we got a negative over negative. This is a positive, so negative, negative, positive. So the answer for this will be positive infinity. Right, so let me do another one. For limit of x approaching -1 on the left hand side for 2x over x minus 2, x plus 1. So we got 2 times -1 over -1, -2, so -3 again. But this time we got 0. So infinity again. To check 0 plus or minus, use some number, -1 on the left, -1.1. So -1.1 plus 1. So this is minus. So negative, negative, negative. This is definitely negative infinity. And then for x equal to 2, so the limit for x approaching 2 on the right hand side, 2x over x minus 2, x plus 1. Substitute x with 2, so 2 times 2. 0 with a plus because we are approaching 2 from the right hand side, times with 3. So this is positive infinity. And then of course another one, the limit as x approaches 2 on the left hand side for 2x over x minus 2, x plus 1. So this is 2 times 2 over 0 and then times with 3. So this is 2 on the left hand side, 1.9. 1.9 minus with 2, so this is negative number. So positive, negative, positive. So this is 4 over 0 with a minus. So this is negative infinity. Therefore, the line x equal to negative 1 and x equal to 2 are vertical asymptote of fx. Okay, so done with the vertical asymptote. So now let us proceed with horizontal asymptote. Okay, so a line y equal to b is a horizontal asymptote of the graph of a function y equal to fx if either the limit for x approaching positive infinity for fx equal to b or the limit for x approaching negative infinity for fx equal to b. Okay, so for vertical asymptote, you can choose either to approach from the right hand side or left hand side. But for horizontal asymptote, you have to check from both of them, positive infinity and negative infinity. Because sometimes you might have different value for both of them. So sebab tu kita kena check dua-dua lah, positive infinity together with negative infinity. Okay. Right, so in figure 8.2.1, as x approaches negative infinity, so this is x, as x going to the left hand side, what can we say is that it never reached the value of 4. So using the limit notation, we state that the limit for x approaches negative infinity, so that means as x go to the left hand side, fx or the value of y will approaching 4. So that is what it means over here. Hence, fx has a horizontal asymptote at y equal to 4. This one, in figure 8.2.2, the graph G approaches but never quite reach the x-axis as x approach infinity. So as we are going to the right hand side, we keep on going to the right hand side, we are approaching the x-axis, but we never reach them, approaching only. Therefore, we can say that the limit as x go to the right hand side of the gx is equal to 0. Maksudnya dia menghampiri nilai y sama dengan kosong. Therefore, we can say that gx has a horizontal asymptote of y equal to 0. Okay, so now determine the horizontal asymptote. So fx equal to x over x minus 2. And then fx equal to 2x squared minus 1 over x squared plus 1. Okay, so let me go to the first one, determine the horizontal asymptote. Okay, so firstly, what do we need to do is that we need to calculate the limit for x approaches positive infinity and the limit for x approaches negative infinity. So positive infinity and negative infinity. Okay, so I check for x approaches positive infinity for fx first. To substitute the function, fx is x over x minus 2. So if you substitute with infinity, you are going to end up with infinity. So substitute with infinity, this one will become infinity. This one is infinity minus 2, which is simply another infinity. So we will end up with infinity over infinity. And if you recall back, if we have infinity over infinity, what do we need to do is that we need to divide with the highest power of our denominator. So in this case, the highest power of our denominator is x. So we are going to divide everything by x. So we are going to have the limit for x approaches positive infinity for x over x over x minus 2 over x. And then, of course, you should simplify them a little bit. X over x, this is 1. And then x minus 2 over x. Simplify them, separate them into two fractions, x over x minus with 2 over x. And then, of course, do you remember if we have the limit for x approaches infinity for 1 over x, this is actually equal to 0. Therefore, the 2 over x, this is actually 0. So this is 1 over 1 minus 0. Therefore, it is simply equal to 1. So one of the horizontal asymptote is y equal to 1. Okay, and then we got to do another one. So this is the limit for x approaches negative infinity for fx. So substitute the function fx. So this is the limit for x approaches negative infinity for x over x minus 2. If you substitute with negative infinity, you are going to end up with negative infinity over negative infinity, which is again infinity over infinity. So that means we should divide with the highest power of our denominator. So the highest power for denominator, again, that is x. So that is why we are dividing them by x. So divide your numerator by x, divide your denominator by x as well. And then simplify them. So x over x is 1, x over x is 1, 2 over x is simply 2 over x. And then do memorize or do remember that the limit for x approaching negative infinity for 1 over x, 1 over x to the power of n, this is actually equal to 0. So that means this 2 over x is simply 0. So 1 over 1 plus 0, so that one will become 1. Therefore, we can say that y equal to 1 is a horizontal asymptote of fx. Now, b. Okay, so b, we got the limit for x approaches infinity for fx, and the function for fx is 2x squared minus 1 over x squared plus with 1. Okay, so I'll give you around 5 minutes for you to try to check what is the limit for this one. So, saya bagi tempoh sikit lah untuk awak kira. Don't forget, you have to calculate the limit. One from negative infinity, another one is positive infinity. So, kena check untuk positive infinity dan juga negative infinity lah. Dua-dua kena check So, 5 minutes tapi from now up until 12:35. think we have the time to continue with the next lecture. Okay, so I think tak apalah, tak perlu lama sangat, tak apa kot. Okay, so let me start with this. Tak jadi nak tunggu sampai 35, 34 je lah. Kita start terus. Okay, so now the limit for x approaches infinity for fx. So substitute the function. This is 2x square minus 1 over x square plus 1. Again, if you try to substitute with infinity, you are going to end up with infinity over infinity. Okay, so since we have infinity over infinity, that means we have to divide with the highest power of our denominator. So based on our denominator, the highest power is x square. Therefore, we should divide everything with x square. Okay, so that means the limit for x approaches infinity. So just in case you couldn't see, I write them again. So this is x approaches infinity. So 2x square minus 1 over x square plus 1 over x square. And then what do? Is that we separate them into two fractions and then we're going to simplify them a bit. So 2x square over x square, it will become 2. 1 over x square, leave them as 1. X square over x square as 1. 1 over x square as 1 over x square. So we got 2 minus 1 over x square. 1 plus 1 over x square. And then the limit for x approaching positive infinity for 1 over x to the power of n. So this is what we learned yesterday. So this is actually equal to 0. So that means this fraction is actually 0. This fraction is also 0. So we are going to get 2. And then basically do the same thing for limit of x approaches negative infinity. So again, if you substitute with negative infinity, you are going to end up with negative infinity over negative infinity. So again, dividing with the highest power of our denominator. So we need to divide with x square again. So 2x square minus 1 over x square. X square plus 1 over x square. Separate them into different fraction. So we got 2 minus 1 over x square. 1 plus 1 over x square. And then another one that we learned yesterday is that the limit for x approaches negative infinity for 1 over x to the power of n, this is also 0. Therefore, this fraction, this is simply 0. This fraction, that is also 0. So we got 2 minus 0 over 1 plus 0, which is simply equal to 2. Therefore, we can say that y equal to 2 is a horizontal asymptote of fx. Okay, so do make sure for horizontal asymptote, you must check from the left hand for positive infinity as well as negative infinity sebab dia pergi ke arah yang berbeza lah. Satu negative infinity, that means we are going to the left hand side, so we need to check that value. And then as we go to the right hand side, we need to check that value as well. So that is why you have to check for both of them. If let's say you have two different value, so that means you have two different horizontal asymptote. If you have the same value, so that means you only have one horizontal asymptote. Okay, so with that, let us start with 8.3 then. So give me a few minutes for me to open the next PowerPoint. So bagi masa sikit saya buka. Okay, so let us start with the next one. Ya, saya ramai yang left. Saya kata saya nak start dengan kuliah yang berikutnya. Sabar je lah. Okay, so basically I want to start with continuity as well. So make sure don't left. Okay, so 8.3 continuity. So let us start around 15 minutes for continuity and then we will continue later on. Okay, so at the end of the lesson, you should be able to explain the continuity of a function at a point and then compute the continuity of a function at a point as well. By the way, this is not 8.2 but it's supposed to be 8.3. So ada correction sikit lah, sorry. Okay, so explain the continuity of a function at a point. So what is the definition of continuity? Right, so a function y equal to fx that can be graphed throughout its domain with one continuous motion of a pen without lifting the pen is an example of a continuous function. Okay, so let us do this together. So make sure pegang pen. So what do we need to do? So dia macam free form je. Try to draw something. Ding. If you drawing them without lifting up your pen, lifting up tu maksudnya tanpa angkat tangan lah. Contohnya macam kita nak buat bulat kan. So kita tak angkat tangan kan. Ataupun kita nak buat huruf M tanpa angkat tangan. So yang ini adalah continuous. But if let's say I want to do huruf apa? Let's say I. Saya buat satu persatu kan. So that means this is not continuous. For example. Okay, so kalau kita boleh lukis straight je tanpa angkat tangan, yang itu adalah continuous. Kalau kata tak boleh, maksudnya yang itu adalah discontinuous. Okay, so for example, this graph. So if you have your pen over here, you can actually follow them without lifting up your pen. So this is actually continuous. Second one, that is also continuous. The third one, if you draw them, firstly you need to draw the left hand side. And then you must lift up your pen before you can draw the right hand side. So this is discontinuous or not continuous. Another one, so if you draw on the left hand side, so yang ini kita draw sebelah kiri. And then kita mesti angkat tangan kita, baru kita boleh draw sebelah kanan. So for this one, we're gonna call them as discontinuous as well. So kalau kata kita tak boleh lukis dia direct je, so dia bukan continuous lah. Okay, so definition of continuity at a point. So a function fx is continuous at a point x equal to c if and only if it meet all three of the following condition. All of them. You must satisfy all of them before we can say that it is continuous. Okay, so what are the conditions? The first one, fc is defined. So what do we mean by FC is defined? That means if you do substitute a certain value of C, we do get some value. For example, if let's say fx is equal to x plus 1, so I can substitute f of 1 equal to 2, so I do get some value. So that means FC is defined. Second, the limit for x approaching C for fx must exist. Since the limit of x approaching C must exist, it simply means that if we do calculate the limit for x approaching C from the right hand side and the limit for x approaching C on the left hand side, they must be equal. Only if they are equal, then the limit for x approaching C must exist. So in order to have the existence of limit, we need to test the left hand side and from the right hand side and make sure we do get some the same value on the left hand side and right hand side. The second one, the third one, sorry. So the third one is actually the conclusion based on the first and the second condition, which is the value of our limit. So the limit for x approaching C for fx, this one must equal to f of C. So dia macam conclusion untuk first dengan second lah. So first tu kita hanya ganti nilai dalam function and then we got to calculate the limit. So if FC is defined, the limit is exists, we need to make sure that the limit as well as the number exactly at that point is the same. Then we can say that it will be continuous. Okay, so these three of them, you must remember them. Okay, so this continuity at a point. So if a function f is not continuous at a point C, we say that f is discontinuous at C or C is a point of discontinuity of f. So kalau kata dia not satisfy any of the condition, it doesn't satisfy any of the condition, we're going to say that f is discontinuous at that certain point, or we can say that certain point is the point of discontinuity. Okay, so example 1. State the definition of the continuity of a function at a point. So simply state the definition. Okay, the first one, fc is defined. So that means we do get some value if we substitute with the value of c inside our function. The second one, the limit for x approaching c for fx must exist. So that means the value of the limit from the left hand side and right hand side of c must be equal. And then the third one, the limit for x approaching c for fx must equal to f of c. So the third one is actually the conclusion for the first and the second. So it concludes those two. Okay, so now let us go to example 2. Discuss the continuity at point x equal to 1, 2, and 3. So we got a function fx over here. And then this is the x. So we need to discuss the continuity. So at x equal to 1, x equal to 2, as well as x equal to 3. So now, if you use your pen and you want to draw, so basically this is 1. We start on the left hand side and then we draw the right hand side. So kena angkat pen ke tak? So I think you can answer that on your own. Do you need to lift up your pen or not? If we draw at 2, do I need to lift up or not? Sebab ni ada satu lagi graph tau dekat 2. So satu yang ini, and then this one. At 3, do I need to lift up my pen or not? Okay, so those are basically based on the graph. So now let us see some calculation or in mathematical way. Okay, so from the graph, at x equal to 1, f of 1 is equal to 0. So how do we see f of 1 is equal to 0? You should look at the dense circle. So the dense circle is over here. So this is x equal to 1. So the value of the y is 1. So that is why we say f of 1 is equal to 0. Kenapa f of 1 equal to 0? F of 1 equal to 1 lah. Next, f of 1 is defined. B. The limit for x approaching 1 from the right hand side for fx. So this is 1 approaching 1 on the right hand side. So this is 1. And the limit for x approaching 1, so this is 1 on the left hand side. This value of y is 0. So that means the limit for x approaching 1 for fx does not exist. Therefore, f is discontinuous at x equal to 1. Why? Because the second condition is not satisfied. So we got 3 conditions over there. So the first one, f of 1, need to be defined first. And the existence of limit, the limit need to be exist before we can do the third conclusion. So since yang second tu not satisfied, then discontinuous. Right, next. Okay, so at x equal to 2, so let us refer to 2 over here. Oops, 2. Okay, so what is f of 2? Okay, so f of 2, this is the dense circle at 2. So the value of y is 2, so f of 2 is equal to 2. Okay, then. F of 2 is defined, yep, because we do get some value, so f of 2 is defined. Next, we need to check the second condition. We have to check the limit. So the limit as x approaching 2 on the right hand side for fx. So this is 2, this is on the right hand side. As we go closer and closer to 2 on the right hand side, we can see that the value of y is equal to 1. So that is why the limit for x approaching 2 on the right hand side for fx is equal to 1. And the limit for x approaching 2 from the left hand side. So this is the function. So we are approaching 2 on the left hand side. And the value of y for this is also 1. So the limit for x approaching 2 on the left hand side for fx is equal to 1. Save. Therefore, I can say that the limit for x approaching 2 for fx must equal to 1 and it exists. Existence of limit. So I do get some limit because the value over here is 1. Now, we need to check the third condition where it's supposed to be a conclusion from the first and second condition. We need to check, are we having the same value or not? So basically, the limit for x approaching 2 for fx is not equal to the value for f2 because this value is 1, this value is 2. They are not equal. Therefore, we can say that f is discontinuous at x equal to 2. So it is also not continuous at x equal to 2. Okay, next. Oh, by the way, yang ini, yang sebelum ni, boleh tak tolong betulkan yang ini jadi bulat ke? Tu graf yang awal-awal tu tukar Jadikan yang awal-awal kat sini bulat. Okay, next. Okay, now let us test for 3 then. At x equal to 3, we need to check is it defined or not. So this is x equal to 3. The value of the y is 2. So I do have f of 3 equal to 2. So that means the value is defined and the value is 2. f3 is defined. So now let us check the limit for x approaches 3 on the left hand side and right hand side. So this is the limit for x approaching 3 on the right hand side. So this is 3. As we approach 3 on the right hand side, we do see that the value of y is actually 2. So that is how I know the limit for x approaching 2 on the right hand side for fx is equal to 2. And the limit for x approaching 3 on the left hand side, so this is 3. We are approaching 3 on the left hand side. And the value of the y is also equal to 2. So the limit for x approaching 3 on the left hand side for fx is equal to 2. So since they are equal, we can make a conclusion such that the limit for x approaching 3 for fx is equal to 2 and it does exist. So now we need to make a conclusion. So based on the first condition and the second condition, do we have equal number or not, or equal value or not? So basically what we can see is that the value for the limit of x approaching 3 for fx, this is 2, and f of 3, that is also 2. So that means the limit for x approaching 3 for fx is equal to the value of f3. Therefore, we can say that f is continuous at x equal to 3. So firstly, substitute the value inside the function first. Check what is the value, is it defined or not? And then check the limit. So for piecewise function, obviously you need to check from the left hand side and right hand side. The existence of limit, test for existence of limit, and then check whether the existence of limit, is it the same value as the value on that point. So kalau sama, baru kita boleh kata dia sebagai continuous. Okay, so I think I stop over here. So next class we're gonna continue with, I think, example 2 of today's. Example 3. Okay, so next class we're gonna continue with example 3. So kita jumpa minggu depan. Bye bye semua orang. Have a nice day. Bye.